In today's notes, we're going to be talking about conditional probability within frequency tables. A conditional probability is the probability of an event given that some other event has already occurred. In the below example, there are two possible events that can occur. A ball could either hit the red shelf, and we'll call this event A, or hit the blue shelf, and we'll call this event B. So this is the probability of hitting the red shelf and the probability of hitting the blue shelf. Now the way that we would write this in a sentence, which is extremely important, is that the probability of A happening given that B has already happened. Notice that in the fraction we take the intersection of A and B and divide it by the probability of just B. So now we're going to apply this to three examples below. So we are looking at males and females who participate in an art studio, a band, technology, and then we have the totals along the sides and the bottom. So the first thing we want to do is set up a fraction. So we have the probability of the art studio given that females. So if we were to write this in a sentence, the probability of choosing an art studio given that you are female. Notice that the first part of the probability, or the first thing that's listed, is also the first thing we say. And the second thing listed is the second thing we say. Now, when we set this up into a fraction, we're going to keep art studio on the top and females on the bottom. So I'm first going to go and look at my females. I know that this is the row that we are looking at. And females is my total. It is the bottom of my fraction. So when I look over at the total for females, I see that that's 54. Now focusing on this same row, those that are female in an art studio are 22. So the probability of choosing an art studio, given that we're only focusing on females, would be 22 over 54. As a fraction, or I'm sorry, as a decimal, that would be 0.41. I'm going to round the 0 to a 1. The 7 rounds 0 up to 1. Or 41%. So the probability of selecting an art studio, or someone who's chosen an art studio, given that they're female, is 41%. The next one we're going to focus on is band given males. So the probability of choosing a man or band, someone choosing a band given that they're a male. So again, band will be the top number, males will be the bottom number. So we're focusing on the male column this time. So I see that if we're focusing on the group being males, we're going to use the total for males, which is 46. And if you're a male, given that you're a male, the probability of you choosing band, we see that there's 18 men that have chose band. That'll be our numerator. 18 over 46, or 18 divide 46, gives us 0.39. The 1 does not change 9, so I'm going to leave 9 by itself. So the probability of someone selecting band, given that they're male, is 39%. So again, if we were to write this as a sentence, would be the probability of choosing band. Notice how band comes first in both, given that you're male. Notice that male comes second in both. So it's super straightforward. It's the same exact sequence. Band comes first, males come second when we write this as a sentence. In our last example, it's the probability of choosing a female, given that they like technology. So this is different. Instead of focusing on the rows, we're going to focus on the column of technology. That is now our given. So, technology is this entire column. So that is what we are focusing on. So the number of people who like technology are 30. So if we set this up, it'll be the probability of female over the probability of technology. So this will be, the probability of technology is 30, that's our total because that's our given. Of choosing a female in technology, well, we're going to look at the second row, 10. So the probability of selecting a female, given that it's in the technology category, is 10 over 30, which is the same as 0.333 repeating, or 33.3%.